In the previous presentation we demonstrated, using a method analogous to that used in Hilbert's paradox of the Grand Hotel, that being in accordance to Cantor's diagonal argument method, assuming that so-called new real number can be created by the diagonal method, a new real number and even infinitely many new real numbers can be added to the infinite set of real numbers, and as a result, the infinite set of real numbers will always remain quantitatively equivalent to the infinite set of natural numbers. Today we will show that the so-called new real number, if such could be created, essentially always already exists among elements of the infinite set of real numbers in the right column of Cantor's diagonal matrix. I welcome you, Adam Polak. Cantor's diagonal method faulty. Case 2. Correction of faulty conclusions from Cantor's diagonal method on the basis of a proper understanding consequences of the quantitative equivalence of the infinite set of natural numbers and the infinite set of even natural numbers. The evidence we will analyze is merely a reinterpretation of the Cantor's diagonal argument method, or rather correction of its erroneous conclusions. It begins with the table matrix used in diagonal argument method, juxtaposing elements of the infinite set of natural numbers with the infinite set of real numbers. According to the assumptions of diagonal argument method, we pretend to construct a new real number. The infinite set of natural numbers is replaced by quantitatively equal the infinite set of even natural numbers. Now, the infinite set of real numbers is quantitatively equal with the infinite set of even natural numbers, which is quantitatively equivalent with the infinite set of natural numbers. To prevent any potential overuse of elements from the infinite set of even natural numbers, the new real number is assigned to another set, namely the infinite set of odd natural numbers. Since the infinite set of real numbers is quantitatively equivalent with the infinite set of even natural numbers, and the new real number is assigned to one of elements of the infinite set of odd natural numbers, the possibility of larger cardinality, more elements, in the infinite set of real numbers compared to cardinality, number of elements, in the infinite set of natural numbers, even and odd, is entirely excluded. It seems quite simple, but let's take a look at it a little differently, to leave even less room for any doubts, if not eliminate any completely. Cantor's diagonal argument, CDA, is an so-called indirect proof. We construct a table, matrix, as an attempt to create a bijection, a one-to-one correspondence between elements of the infinite set of natural numbers and elements of the infinite set of real numbers from interval 0, 1. The initial assumption of Cantor's diagonal argument is that in the left column of the table, in successive rows, there are all natural numbers, while in the right column of the table, in successive rows, there are all real numbers from the interval 0, 1 in a random order, assigned one-to-one to the successive natural numbers from the left column. That means every real number has a corresponding one-to-one natural number, and every natural number has a corresponding one-to-one real number. Here we are. We see Cantor's diagonal argument matrix. Now we will take a look at the CDA matrix from a slightly different perspective. Not from the perspective of the infinite set of natural numbers, but from the perspective of the infinite set of odd natural numbers, and at the same time the perspective of the infinite set of even natural numbers. Those two infinite sets represent the same cardinality, number of elements, as the infinite set of natural numbers, and when put together, they simply create an infinite set of natural numbers. What we do now is very simple. We just split the standard Cantor's diagonal argument matrix into two matrices. The starting one have the natural numbers in the left column and corresponding to them real numbers in the right column. We split it into two matrices. The first one have odd natural numbers in the left column and corresponding to them real numbers as before, and the second one have even natural numbers in the left column and in the right column real numbers corresponding to them as before. Now, as it always takes place in Cantor's diagonal argument method, we pretend to create a so-called new real number. First, we create the new real number from the matrix of odd natural numbers and corresponding to them real numbers. And now we do exactly the same with the second matrix of even natural numbers and corresponding to them real numbers. Finally, we have two so-called new real numbers. Because the initial assumption of Cantor's diagonal argument is that in the left column of the table, in successive rows, there are all natural numbers, while in the right column of the table, in successive rows, there are all real numbers from interval 0, 1, there is no possibility to challenge the fact that the new real number created of the matrix of real numbers associated with odd natural numbers always already resides within the matrix of real numbers associated with even natural numbers, and the new real number created of the matrix of real numbers associated with even natural numbers always already resides within the matrix of real numbers associated with odd natural numbers. The possibility of larger cardinality, more elements, in the infinite set of real numbers compared to cardinality, number of elements, in the infinite set of natural numbers is entirely excluded. Thank you for watching, and I already invite you for the next presentation in which we will indicate another very important error faulty of Cantor's diagonal argument. Adam Polak.